So welcome to this latest video on 162 Maths, and in this video we'll be continuing the series of going through some GCSE Maths higher big mark questions. Now, as always, there'll be a copy of the questions that we go through in this video. It's a link for you to download and have an attempt at before watching through this video. Now, before we get started, a little reminder that a copy of the questions that we go through are available as a link in the description below, along with the mark scheme, and I strongly recommend you have an attempt at these questions before watching through this video as we go through the answers, just so that you can test your knowledge. Now, majority of the questions on this video are all calculator based. However, if you want to have a go with it without using a calculator, just to prove and just to practice your non-calculator skills, then that is fine. But all of these questions are taken from a calculator paper. So let's get straight on to question 1, which is related to histograms. So question 1 reads, 61 students recorded how many hours they spent revising for a test. The histogram represents the results, and for part A it's asking us to work out the estimate of the mean time for the 61 students spent revising. Now, to work out the estimated mean time, we need to look at the formula. So the estimated mean, because it's group data, is the sum of fx over the sum of the frequency. Now, for this, what we need to do first, using the histogram, is we need to first of all work out what the frequency is for each of the groups. So here we know that the frequency is equal to the area of the bar. So first things first, to work out the frequency, we just need to work out the area of each bar. So this is going to be 1.5 multiplied by the width, which is 6. So 1.5 times 6 gives me an answer of 9. Then for the next one, we've got 3.5 multiplied by 4, which gives us an answer of 14. For the third bar, here we've got a height of 5, so that's going to be 5 times the width, which is 2, which is equal to 10. And then for the fourth bar, we've got 4.5 multiplied by 4, as it's 16 take away 12, which gives us an answer of 18. And for question 6, or for the last bar, it's going to be 2.5 multiplied by 4, which gives us an answer of 10. So here what we've got is we've now got the frequency of each group. So in the table, so that's going to be 9, 14, 10, 18, and 10. Now, to work out the midpoint, all I need to do for this is do the upper bound plus the lower bound and divide it by 2. So here 0 plus 6 is 6, divided by 2 gives me 3. 10 plus 6 is 16, divided by 2 is 8. And then I can, or you can just simply fill it in. You don't really need calculating, but if you are finding it a struggle, then that's all we need to do. Now again, going back to the estimated mean, the formula is the sum of fx over the sum of f. Now we know that it tells us we've got a frequency of 61, so that should be 61. And then here, all I need to do then is create my fx column. Now, how I get my fx values is by multiplying the frequency by the midpoint, and that will give me my fx values. And again, if I just type that all into my calculator, I'm going to get an answer of 27, 112, 110, 252, and 180, which gives me a total sum of fx as 681. So here the estimated mean is going to be 681 divided by 61, which if I type into my calculator gives me an answer of 11.1639. And again, depending on whether you want to round the answer up, it doesn't tell you how they want the answer rounded up. So I'm going to round up to 1 decimal place to 11.2, but they would accept any answer between 11.16 to 11.2. So as long as your answer is between that region, you'll be fine for the full marks. Moving on to B, it says give a reason why the answer part A is just an estimate, and you can give any of these possible valid answers. So you could say that the midpoints are used. You could also say that raw data is not used, it's not given. So something along those lines. Or you could say that group data is used. So any of those statements would be fine for that 1 mark. Now moving on to question 2, it says B is 60 miles from A on a bearing of 170 degrees. A ship sails from A on a bearing of 247 degrees. It travels at a constant speed of 23 miles per hour for 1.5 hours. Is the ship now closer to B than it was when it left A, and you must show you're working out. So let's have a look at what information we've been given. So first of all, we know that B is 60 miles from A on a bearing of a 170, which is represented by the diagram. Now the next thing for us to do is then show this information. So it then says that a ship sails from A on a bearing of 247. Now again, we don't need to use accurately, but 247, well, here is 270, this is 180, so 247 is going to be somewhere around here, let's say. So let's just call that ship A. Now the second bit of information, so then what I can then do is that angle there, if I just colour it in orange, is 247. So I can then work out what this angle here is going to be by doing 247 minus 170, which gives me an answer of 77 degrees. So this angle here is 77 degrees. It then says that it travels at a constant speed of 23 miles per hour for 1.5 hours. Now again, to work out the distance of A from this point here is then what we then need to do is to use the formula of distance equals speed times time. Now because the units of speed is in miles per hour, they need to make sure the distance is in miles and the time is in hours. So here the distance is going to be the speed, which is 23, multiplied by the hours in hours of 1.5, and if I type that into my calculator, I get an answer of 34.5 miles. So this length here is going to be 34.5 miles. And what the question's asking is, what is this length here, and is that shorter than 60? So if I just call this X, so is X less or more, or should I say it's definitely less because you're asking where it's closer. So is X less than 60? And this is the question that we need to ask to find out. So if I take this triangle out, so let me just draw that triangle. I know that this angle here is 77. I know this angle here is 60. I know that this length here is 34.5. And what I need to do is I need to work out what this is. Now taking the triangle out of the actual diagram, you can see there that we've now got a advanced trig question, which is then they're going to be therefore using the cosine rule because I've got 3 sides and 1 angle. So again, the cosine rule reads a squared equals b squared plus c squared minus 2bc cos a. So looking at the values and just labeling, this is going to be my capital A, that's going to be lowercase a, and this is going to be my b, and that's going to be my c. So substituting those values in, I get x squared is going to equal 60 squared, or no, 34.5 squared. Now if you've done the opposite sides for b and c, it's not a problem. It's not going to affect the question, or your solution rather. So we've got 34.5 multiplied by 60 times cos 77. If I type that all into my calculator, I get an x squared value of 3858.95, which rounded or square rooted gives me an answer of 62.12. So therefore, going back to this question of is x less than 60, well, the answer then is no, as 62.1 is greater than 60. And there is my final answer for that one. Now moving on to question 3, it says two congruent parallelograms PQRV and VRST are joined. The vector of Q to P is equal to A and the vector of P to V is equal to B. X is a midpoint of VT where V to W and W to R is in the ratio of 1 to 2. And the question is asking us to prove that Q, W, X lie on a straight line. Now to prove Q, W and X lie on a line, then what we need to show is that Q to W is a factor or multiple of W to X. So this is the proof that I then need to go on to prove. Now the key bits of information I need is basically I need to work out what Q to W is, and I also need to work out what W to X is. Now without those two bits of information I will not be able to prove that this is the case. So let's have a look at this information here. So ultimately I want to go from Q to W, which at this moment in time I can't do because I've got this little gap here that I don't know, in which I could go this route. And let me just get a yellow pen if possible. There we go. So Q to W, I'm going to go from Q to P, then P to V, and then V to W. And I then need to work out what W to X is. So W to X, which is this route here. So W to X, I'm going to go W to V, and then V to X. So Q to P I know. So if I just take this out first, so Q to P is equal to A. P to V is equal to B. And it's V to W that I don't know. And likewise, in terms of this, now we know as they're congruent, then this length here is also going to be B. So V to X is going to be a half B. And W to V is something I don't know. So the two things I need to work out are these two. And where this comes from in the particular question is basically using this bit of information here. So from this, what we can then do is we know that V to R, actually let's use different colours so not to get confused. So we know that V to R, so going from here to here, is going to be minus A, as it's going in the opposite direction of the arrow going from Q to P. So from this, what we can then do is we can then use this ratio here of V to R to then see that V to W to R, and as it's in the ratio of 1 to 2, we split minus A into 3 parts. So minus A divided by 3 gives me minus 1/3 A. And using this, so then V to W is therefore going to be minus 1/3 A. And W to R is going to be twice as big, so that's going to be minus 2/3 of A. Now from this, what I can then do is label the diagram. So let me just get rid of some of these markings. So then from this, I've then worked out that V to W going in this direction is minus 1/3 A, and W to R is minus 2/3 A. And again, please make sure that you're aware of the arrows that we are drawing. So from this, I could then work out what the V to W is. So V to W is now going to be minus 1/3 A, and W to V is now minus 2/3 A. So from this, I can now work out what those two lengths are going to be. So here to then work out, let's use another colour to make it stand out. Let's go for lilac. So here we've then got that we can then work out what Q to W is. Well, Q to W is A plus B minus 1/3 A, which gives me an answer of B, and that's going to be plus 2/3 A. And I can then work out what W to X is going to be, and that's W to V, which is positive 1/3 A, plus, and that's going to be a half B. Half B. So then what I'm comparing is I'm comparing this to this. So what do I have to do to get from one to the other? Well, from this I can then see that 2 lots of WX is equal to Q to W. So therefore Q, W and X lie on a straight line. Alternatively, what you could also say is that a half QW equals wx. That will be also fine. And again, showing that one is a factor or a multiple of the other is good enough to prove that it is on a straight line. Next, we move on to question 4. Now, question 4 says Helena ran 800-meter race in 140 seconds. The speed time graph represents the first 100 seconds of her run. Helena ran the last 40 seconds with a constant deceleration, and it says work out her speed as she finishes the race. Now, for this question to make sense, which I know has come up a lot of times, and I would say is a question that through all my years of teaching maths at GCSE level, this question, whenever it's come up, has always stumped quite a lot of students. Now, typically, when you see the fact that Helena's ran the last 40 seconds in constant deceleration, you're then thinking, well, 100 seconds, she finishes at 140, so the graph must end up looking like this. Now, if you try and gauge an understanding about what this actually means, it will show that this, in fact, is actually wrong. Now, if you imagine you're running towards a finish line, this is giving the impression that as you get closer and closer and closer to the finish line, that your speed, when you hit that 40, is going to be 0, which is not the case because you're not within like a centimetre, you're not virtually at standstill. So what's actually going to happen is that you're going to finish past the finish line at a speed. Now, we don't know what that speed is, so actually the graph is actually going to look something like this. Now, we know that Helena is going to slow down because it says at a constant deceleration, but it doesn't mean that she's going to cross the line at 0 meters per second. So we don't actually know what this length here is going to be, but we know that it's going to be somewhere between 0 and 6. And that's what we need to find out. So we need to find out what this x value here is going to be. Now, for this, what we then need to do is first of all work out that the distance of a speed time graph is basically the area under the curve, or in this case lines. So if I work out the area, if I just label these parts up, so let's label this triangle A and this rectangle B. So the area of A is going to be 10 times 6 divided by 2, as it's a triangle. So that's going to give me an area of 30. So this area here is 30 meters. Then for B, so area of B is going to be 100 take away 10, which is 90, multiplied by the height, which is 6, and that gives me 90 times 6, which is 540 meters. So this area here is 540. So to work out the area of C, which we know is going to be a trapezium, but the area of C is going to be 800 because that's the total distance, minus these two lengths, so 30 minus 540, and that's going to give me an area of 230 meters. So the area here is 230. Now, as you can see, we've got that area C is a trapezium, and to work out the area of a trapezium, if I call this side A, this side is going to be B, and this is going to be H, we know that the area of a trapezium is a half A plus B times H, or A plus B times H divided by 2, whichever floats your boat in which formula you're wanting to know. Now, I know that the area of C is 230. I know that X, which is what I don't know, so I'm going to go for X plus B, which I do know is 6, multiplied by H, or the height, which is 40, and I'm going to divide that by 2. And remember, X is what we're trying to work out. So from this, all I've got to do is a bit of rearranging. So I'm going to get 460 equals X plus 6 multiplied by 40. Then take the 40 over, in which then, if I type that into my calculator, I get 460 divided by 40 gives me an answer of 11.5, and that equals X plus 6. So then that leaves me an answer of 5.5. So then to answer the question, work out a speed that she finishes the race at, it's going to be 5.5 meters per second. Then moving on to question 5, it says that in a class there are n boys and a total of 25 students. 2 of the students are chosen at random. The probability that both students are boys is 7/20. Work out the value of n. So in this particular case, let's first of all write down some algebra notation. So we know that the boys, there are n number of boys. So to work out the number of girls, well, that's going to be a total of 25, take away the number of boys. So from this, what we've then got is then if we're going to choose a boy first, so the probability of a boy and another boy is equal to 7/20. So if we take the contents of this, well, the probability that the first person picked is a boy is going to be n/25 multiplied. Now the probability of the second person being a boy, well, the number of boys now, if one's been taken, is going to be n take away 1. And then the number of people there are in the class, if one's already been taken, is going to be 24. And we know that that is equal to 7/20. Now what this then becomes is an algebraic fraction, so we need to neaten these two things here up. So again, multiplying fractions, we multiply the numerators, multiply the denominators, so end up with n minus 1 over 25 times 24, which basically gives me an answer of 600. And let me just double check that to make sure that is correct. So 25 times 24 is indeed 600. And that is equal to 7/20. Now from this, what I can then do is take the 600 over to the other side. So I end up with n minus 1 equals 600 times 7/20. And that's going to give me an answer of 210. So let me just get rid of that and I can write 210. Expanding the brackets, I get n squared minus n equals 210. And hopefully now at this stage you can then see that it looks like a quadratic. So if I make it equal to 0, I can then factorize it. So I've got n minus or plus 14, n minus 15, or you could use the quadratic formula to solve it if you didn't spot that the numbers inside brackets are going to be 14 and 15. So here I get an answer of n equals minus 14 or positive 15. Now because n represents the number of boys, you can't have a negative number, so it can't be this. So n can't be negative. So therefore the only possible answer for n is going to be positive 15. Then moving on to the last question of this big mark sheet, it says ABCDE is a pentagon, and it says work out the area of the pentagon. So again, because we've got a compound shape, I'm going to label this trapezium A and this B. So the total area is equal to area of A plus the area of B. So working out the area of A, which is a trapezium, that's going to be my A value, that's B, and that's going to be H. So this is going to be 14 plus 20 multiplied by 11 divided by 2. And if I type that all into my calculator, I get an answer of 187. Then to work out the area of B, which is a triangle, we've got the base and the height, so that's going to be 10 times 7 divided by 2, which gives me an answer of 35. So the total area is going to be 187 plus 35, which gives me a final answer of 222, and that's in centimetre square. Now again, if you have the correct answer of any of these 6 questions that we've gone through, but your method has been slightly different, by all means it may still get the same mark. I've just gone for probably the most easiest and most efficient way of getting the questions. But if your answer is you're working out slightly different, please do check with the mark scheme, which is attached in the description in the video that you're watching.